We're going to make a very important statement about energy transfer, and it is this, that whenever energy changes from one form into another, some energy will always be lost in the transformation. Whenever energy changes from one form into another, some energy is always, and we're going to put that in capital letters because we really want to emphasize this, it is always lost in every change, and this lost energy cannot be recovered. That's to say, it is lost forever. Now, to demonstrate this, let's consider this ball. We're going to release it from a fixed height. So at the moment I'm holding the ball in a fixed position, and the ball possesses a stored energy called gravitational potential energy. Now, as soon as I release the ball, it starts to fall towards the ground under the force of gravity. And as it does so, that gravitational potential energy is changed into another form of energy called kinetic energy. So as the ball's falling, the gravitational potential energy is changed into kinetic energy, and then as soon as it hits the ground, the ball will start to compress slightly, and that kinetic energy will then be stored again as elastic potential energy in the ball. That elastic potential energy will then be changed back in to kinetic energy, and the ball will start to rise again. Eventually it will reach its highest point, and that kinetic energy will have been changed back again into gravitational potential energy. But you'll notice that, providing the ball is dropped, not thrown, that it is dropped, that the ball never reaches the same height. Let's think about why. When we drop the ball, a number of different energy changes take place. We start with gravitational potential energy. That is then changed into kinetic energy as the ball drops towards the earth, which is then changed into elastic potential energy as the ball hits the ground, which is then changed back again into kinetic energy, which is changed back into gravitational potential energy as the ball rises. So our statement about energy says that whenever any of these energy changes takes place, some energy will always be lost, and this energy cannot be recovered again by the ball. So as the ball falls, we're going to lose some energy. When the kinetic energy is changed into elastic potential energy, we lose energy. When it's changed back into kinetic energy again, we'll lose some energy. And as that kinetic energy is changed back into gravitational potential energy as the ball rises, we'll lose some more energy. So we can say that energy is lost. Now, how is that energy lost? Well, the air around the ball is made up of tiny little particles which are invisible but are moving continuously, and as the ball passes through these particles, some of its kinetic energy is transferred into movement energy of the particles. Another way of looking at that is to say that kinetic energy of the ball is transferred to heat energy in the surrounding particles. So we can say that the ball causes the temperature of the particles to increase very slightly as it passes through them, due to the fact that kinetic energy is changed into heat. Likewise, the same happens as the ball compresses and kinetic energy is changed into elastic energy at the ground. The ball will heat up slightly and energy will be lost in the form of heat. So the ball will never rise to the same height from which it was dropped, because some of its energy will always be lost forever to heat in the surrounding particles. So we can calculate the amount of energy that was lost as the ball fell and rose again by calculating the difference between the initial gravitational potential energy, let's call that GPEI for initial, and the final gravitational potential energy, F. So the energy lost during transfer will be equal to, let's put this, the energy lost, and this is lost in the form of heat, will be equal to the initial GPE, that's that little I there for initial, that's the starting GPE here, minus the final GPE, that's the gravitational potential energy of the ball when it returned again after bouncing. So all we've got to do is calculate this difference. Now we're not going to do this here, but you can do this in the Check Understanding quiz that follows this video tutorial, and that will lead you through the steps of calculating the energy lost when a ball bounces.